All right, this is Professor Clark. We're back into Chapter 4 talking about causation. We're in Section 4.2 today, talking about the difference between an observational study and a controlled experiment. If you think back to the 4 pillars of inference, we're on the 4th pillar, which is causation. So what is the difference between an observational study and an experiment? Well, in an observational study, you're just observing. You're just looking at the world as it is. Any groups you can find are sort of just there. They're defined rather by what you see rather than what you do. So, for instance, yesterday we talked about the children with the nightlight on. The researchers didn't control which children had the nightlight on. They just asked the parents whether they had the nightlight on or not, and then they looked at the data after the fact. The problem with an observational study is despite the fact it can tell you interesting things, there's typically confounding variables at play. So in the nightlight study, we realized that whether or not the parent was nearsighted was a confounding variable, and then therefore we weren't able to draw a cause and effect relationship between whether the nightlight was on and whether the students or the children developed nearsightedness, because we thought, well, actually maybe it was the parents. So this lack of control, this presence of confounding variables, prevents the cause and effect relationship. And what we would like to do is to be able to move past that. We'd like to be able to design studies that actually get at cause and effect. So contrast that with an experiment. So in an experiment, you actively create groups and you assign the conditions to be compared. So conditions can be set as treatments or a control. So in the nightlight, you could have the idea of a student or a young child sleeping with a nightlight on. Maybe that would be the treatment, and the control would be to sleep in the dark. And then you could look and see what happens, but you could randomize which kids got the nightlight and which kids got the slept in the dark. And so actually maybe there was some parents who were nearsighted and some parents who weren't in the nightlight scenario, and some parents who were nearsighted and some parents who weren't in the sleeping in the dark, and therefore you couldn't say, well, it wasn't the fact that the parent was nearsighted, because you randomly assign which kids went into which group. So well-designed experiments, they control for confounding variables by making the treatment groups similar except for what the experimenter manipulates. And so in this sense, the treatment groups would have, randomly an assortment of some parents with nearsightedness, some parents without, in both groups. And so the only difference would be between the groups would be whether the kids had the nightlight on or not, for that example. The confounding variables are therefore controlled due to the random assignment of subjects to treatments. So because the subjects aren't observed and the groups are created after the fact, that you are assigning them. So randomly assigning people to groups tends to balance out the other variables. Variables that could have an effect should be equalized between the groups, because the groups are randomly made. You're not going to get all men in one group and all women in the other group, or all people who are nearsighted in one group and people who aren't nearsighted in the other group. They're going to be randomly mixed between the two. So randomness is the key. The groups are going to be, on average, very similar. And therefore, if there's a difference, the only explanation for the difference would be the difference between the treatment and the control, whether they had the nightlight on or not. So if you did see a difference, you can't say, well, it's because of this, because all of those things are randomly assigned. So in this case, with an experiment like this, a cause and effect relationship is possible. So let's do an example. Let's look at, say, Facebook friend requests. Maybe you've gotten a friend request in the past from somebody you don't know, and you're wondering, well, how did I get a friend request from somebody I don't know? Well, did you accept the request? Did you look to see if you had any mutual friends? And the question we're going to look at is, does that person's gender affect whether you accepted them? So here is the study. Researchers created 2 fake Facebook profiles of students. The sample was a group of 219 students at a college. 118 were randomly assigned to a female student, and 101 were randomly assigned to receive a male student. So they basically created one female and one male Facebook profile, and then they flipped a coin with each of the 219 students, and if the coin said heads, they gave them this one, and if the coin said tails, they gave them this one, or something like that. So they were randomly associated to one or the other invites, and that's why they're not exactly the same number. All right. So because of this, it's not like we took all of the football players at the college and we had them get the female Facebook invite and all the non-football players at the college and had them receive the male invite. It's, all of these 219 students were randomly assigned, so you figure that these 118 students are pretty similar to these 101 students on average, and that's the key. So therefore, the only difference between these two groups is whether they got a friend request from a quote-unquote female student or a quote-unquote male student. Both of these were fake. So what do you think happened in the data? Yeah. Let's see. So it turned out the female Facebook profile, 61 out of 118 times, that person was accepted. And the male Facebook profile, 18 out of 101 times, that person was accepted. Now, 61 out of 118, that's pretty close to a half, and 18 out of 101, that's pretty close to 20%. So we got 50% versus 20%, or pretty close to it. Those are not the same, so it seems like something else is going on here. So is this an observational study or an experiment? Well, it's an experiment because we randomly assign which students would get the female invite and which students would get an invite from a quote-unquote male student. What are the observational units? We actually call them experimental units when it's an experiment. Well, it would be the 219 students that received invites. That's who we're observing. And the explanatory variable in this case is categorical. It's whether they received an invite from a female or a male. And the response variable is also categorical. It's whether they said yes or no. So we've got categorical variables explaining and categorical variables responding. Now the next thing you might want to know is, was the study random or was it a random sample? Well, the students themselves, it doesn't say it was a random sample of students. So we might have a problem with generalization here because maybe they just picked 219 football players or something like that. And so maybe those students aren't representative of all students at the college. But if this were a random sample or a representative sample of the students at a college, then we'd probably feel pretty good about that. So was it a random sample? It didn't say that it was a random sample. So we would have trouble generalizing to other colleges, and we would probably also have trouble generalizing to adults because, well, all the students in our sample were students. They weren't adults. Or they weren't, 35-year-old adults or whatever. They were all college students. So did this study have random assignment? Yes. We randomly assigned whether they got a male or female invite. And so that means we can say that the gender or the sex of the fake profile is affecting the acceptance rates. I think we can. Because this is a controlled experiment. And so here's kind of a table that kind of tells you the difference between random assignment and random sampling. So first, let's look at random sampling. So you have these 219 students. Are they a random sample or not? Well, if they're a random sample, okay, then we should be able to infer to the population. We should be able to say, well, these students were randomly sampled from the whole population of students, and therefore we can generalize to the population. If the students weren't random sampled, if it was all music students or all female students or all some kind of students that lived in one dorm or something, if it wasn't representative and it wasn't random, then you would have a potential for sampling bias. So random samples give a good likelihood of being representative. Non-random samples could be representative, but maybe not, and so there's that potential for sampling bias. All right. When it comes to assignment, did we randomly assign the variables, the treatments? Well, if we did, we should be able to draw cause and effect relationships. If we didn't, then there's the potential for confounding variables. If we just gave all the male students male invites and all the female students female invites, then our data might be confounded by the fact that, which students got the invites. But the fact that we randomly assign them, and we should be able to draw a cause and effect, because the only thing that was different was whether they got a male or a female student invitation. All right. There's one more notion here, the notion of blocking and random assignment. So the goal of random assignment is to make the groups as similar as possible. But it is possible by random chance that you could get more. Let's take, for instance, men and women. So if you have 20 people in your sample and 10 are women and 10 are men, it could be by chance you get 15 women in one, or maybe 8 women in one and only 2 women in the other or something. That's possible with random chance. So one of the things you might do is say, okay, we've got 10 men and 10 women. We want to randomly assign them to the 2 treatments. Let's randomly we'll take 5 of the women and 5 of the women. We'll randomly assign those 5 and those 5 to the 2 treatments. So we know we get 5 in one group and 5 in another group, and then 5 men and 5 men, or something like that. So we can do what's called blocking, where we say, okay, we want to make sure we get a good variety of, say, men and women in both samples. And so we randomly assign between the men, and we randomly assign between the women. And you might do this if you think that gender is likely to be a confounding variable, and so this allows you to control for that. If your subjects in your sample were, say, 60% female and 40% male, then maybe each group has 60% females in it and 40% males in it, but which females and which males get into which group is still randomly assigned. You just make sure you get an even number in each. Oftentimes it's more feasible to randomly assign subjects to groups to make them as similar as possible, but sometimes blocking can be helpful if there's one thing that you think could be a difference, and so you can account for that. So that's one example. I want to look at, if you're reading through the book, I want to just point out a few things that was in the book that wasn't in the example we talked about here. So the book has a problem about whether people will lie on the internet or not. So are you more likely to tell a lie through email than with pencil and paper? This is an interesting question, because maybe you've seen on the internet people, maybe say things on the internet that they wouldn't say to your face. Well, why is there a difference between how you behave on the internet and how you behave in the real world? So they wanted to study this. So they got 48 students in a business graduate students, and they participated in a bargaining game, and they wanted to keep track whether the students would lie about the size of the pot when they were negotiating with other players. So they had some situation where they could misrepresent the value of the thing that they were bargaining over. So the question is, does the internet encourage lying? And they thought, well, how about when they're talking to each other? One way is they could use email to communicate, and another way they could use pencil and paper and pass notes between each other. And they wanted to know, well, is there a difference between whether people lie more if they're using email than if they're using pencil and paper? Okay? And they thought that the ones who were using email would lie more often. All right. So that's sort of the question they're working with. In this case, let's think about what are the explanatory and response variables. So the explanatory variables is whether they're using the internet, email communication, or pencil and paper communication, the type of communication. And the response variable is sort of how many of them misrepresented the size of the pot. Is it an observational or an experiment? Well, it's an experiment because we're going to randomly assign students to the two groups. One group will be using the email, one group will be using the pencil and paper. And so we're not just looking at people's behavior, we're actually assigning behaviors to the students and then seeing what happens. So here's the idea of the difference between an observational study and an experiment. We're actively creating the groups and then we're seeing what happens. So suppose there's 30 male and 18 female students, and you wanted, if you had all 30 men in the sample on the internet and all 18 women use pencil and paper, well, you've just baked a confounding variable into your sample because maybe men and women behave differently when it comes to lying. And so if you try to compare these two groups, you've got trouble. So if you want to draw conclusions, you've essentially created a confounding variable. And now you're not going to know, is it because of the method they were using or is it because of the gender? And so what would be better is to maybe take these 30 men and assign 15 to the pencil and paper and 15 to the email communication. Take the women, assign 9 to the email communication and 9 to the pencil and paper. And then you've got a good block design where men and women are equally represented in both groups. You could also just take all 48 and randomly assign them to both, and probably by chance you'd get a similar makeup in both, but maybe not. All right. So that's what this is talking about here. We want the comparative study is balanced with respect to a possible confounding variable. So that's the idea of the block design. All right. Randomly assigning experimental units to groups tends to balance out the other variables. So even if we just randomly assign, it would probably work out that we'd get a good number of men and women in both studies and it would be fine. But when you have something that you suspect could be a confounding variable, blocking can be good. All right, so let's say you do this experiment and you observe a difference in lying between the internet and a pencil and paper. So there's only two explanations. Either there's a cause and effect relationship or the difference was due to random chance stemming from the random assignment process. That is a possibility. However, it's probably more likely that it's some kind of cause and effect relationship because the random chance, that's sort of a less likely thing, that somehow randomly all the people who lie got put into one group. Is that possible? Sure. But it's less likely because we randomly assigned. All right. Here's kind of some ideas with the randomization. If we get rid of the confounding variable, then we're able to have a better chance at inferring whether they lied or not. So the confounding variable, we want to get rid of that. So what happened when they do it? Well, they found out that 24 of the 26 people who used email, so 92%, were guilty of lying. 14 of 22, so still quite a few, lied when they used pencil and paper. But that's a difference. Like, that's not the same. Now, in Chapter 5, we'll actually learn about how do you quantify, how do you construct a p-value about how different these two numbers are. But just, based on looking at them, it seems like those numbers are pretty different. And so we should be able to infer, therefore, that because if you actually do this, you get a small p-value. We'll learn how to do it later, but you get a 0.015, so that means the probability that this is happening by chance is very, very small. So it must be that the method of communication is influencing whether they lie. And then we can formulate conclusions. In this case, we believe that the format of the game, actually affected how people played the game. All right, and this is kind of the big picture. No random assignment, no cause-effect conclusions. That's the big idea. Now, there's some question about whether you can generalize this to say, well, now I know that people lie on the internet. Well, these are sort of like a quasi-experiment, okay? So these kids were playing a game. They may not behave the same way. 92% were lying on the internet. Is that true that 92% of people lie on the internet? Well, they lie in this situation, and so we got to be careful. Even though we can draw a cause and effect relationship, we can't necessarily generalize that and say that people lie all the time on the internet no matter what. All right. There's one last thing, is the idea of double blind. So if the subjects don't know that they're using the internet and the other people aren't, that would be blind, which is good because they might behave differently if you told them ahead of time, well, you guys are using the internet and the other people aren't, and we're trying to figure out if you guys are lying or not. You know, we don't want to do that. In a double blind, neither the subjects nor those evaluating the response know what was happening. Now, in this case, it was pretty clear if they were lying or not, but you could imagine something that's more subtle. You know, if it was a doctor and they had to decide if somebody was looking healthy or not. Well, if they knew they were taking the new medicine, they might be like, oh yeah, he's looking good, you know, and if they weren't, they'd be like, well, maybe not. So really good studies are double blind if there's any sort of potential for people to either change their behavior based on knowing that they're part of a study, or people who are measuring their behavior to do it incorrectly. All right, so what did you learn? You should be able to identify a study as either an observational study or an experimental study. You should be able to identify if a study uses random assignment or random sampling. You should know, well, what can you imply if a study has random assignment? Well, that's when you can use cause and effect. Why can you infer that? Well, because the only thing that could possibly have caused it is, in fact, the difference in treatments. And the random assignment ensures that the treatment groups are similar, so that's the whole point. And if a study has random sampling, that allows you to generalize it to the population.